Welcome to another video on matrices. Now matrices, the plural is matrices, whereby singular is matrix. Matrix was introduced by an English mathematician who is known as James Sylvester. But his friend, who is known as Otto Seeley, was the one that developed algebraic aspect of the matrices. Now, our concern is what matrices is. A matrix can be defined as matrix is simply defined as a rectangular array of numbers enclosed in brackets. Now, when you have this bracket like this, another bracket, you have A11, A12, A13. You have A21, A22, A23, A31, A32, A33. Now if you check this is rows. Anything that goes like this is row, and this is column. Now if you check this bracket here, that shows that this first one is row 1, this one is row 2, and this is row 3. This is column 1, this is column 2, and this is column 3. Now when you check this, that means when you check this A11 that is there, it means that row 1, column 1, this belongs to row 1, but in column 2. That's why it is A12. This one is A13. It belongs to row 1, but column 3. If you check this one, this belongs to row 2, but column 1. That's why it is A21. This one belongs to row 2, column 2. This one belongs to row 2, column 3. This one belongs to row 3, column 1, row 3, column 2, row 3, column 3. That is it. Now, we have, if you check an example, if you have 7, 2, 6, 1, 4, 5. If you check this very well, you will observe that this 7 is in row 1. This one is also row 2. This is column 1. This is column 2. This is column 3. Now, if you observe very well, this 7 belongs to row 1, but column 1. This one belongs to row 1, but column 2. This belongs to row 1, but column 3. This belongs to row 2. We check, but column 1. This belongs to row 2, but column 2. This belongs to row 2, but column 3. This is what we know as the order of a matrix. The order of a matrix. Now we have to deal with some terminologies. Or I will even say some matrix terminologies. The first one, a row matrix. A row matrix, this consists of one row. This consists of one row only. One row only, if you are talking about one row only, That means if you have this, for example, 7 2 8. Check this. This consists of only one row because this is just only one row, but it contains 3 columns. It does not matter, but it contains just only one row. Now if you have this 1 5, this one as well only contain one row, but it contains what? 2 columns. But don't forget, we are talking about a row matrix. So any matrix that contains only one row is called a row matrix. Number 2, a column matrix. A column matrix. Now what do we mean by a column matrix? This consists of one column only. This consists of one column only. For example, if you have 2 4 7, 2 4 7, though it consists of three rows, but don't forget it is only one column, like this. Another example, if you have 419, this 419 only contains one column, but it consists of what? 3 rows, if you check it. But what we are dealing with here is any matrix that contain only one word, only one column. That is it. Number 3 is order of a matrix. When you're talking about the order of a matrix, order of a matrix is like this. If you have 1 4 7 2 8 5, order of a matrix will contain row. We have it to be row against column. It is row against column. So we have this now. This matrix, it has one row, second row. If we check this one contains first column, second column, third column. So we now have the order of this matrix to be 2 by 3 because of it contains 2 rows, but what? But 3 columns. 2 rows, but 3 columns. That is how we do the order of a matrix. Now another example, if you have 1 5 6, 1 5 6 here, if you check it very well, it contains 1 2 3 rows, but the only one as a what? As a column. So it only contains one column. This is first row, second row, third row, but it only contains one column. So it is 3 by 1. This is order of a matrix. Let's do another one. We have 4 2 6 8. Now if you check this very well, this one contains first row, second row, first column, second column. So this is 2 by 2. But don't forget the rows come first before the column. Another one. If you have 4 6 2 5 8 9, this one contains the first row, second row, third row, but the first column, second column. So this is 3 by 2 matrix. Now let's get to another aspect. So this is order of a matrix. Number 4 now. Number 4, we have what is known as a square matrix. What is a square matrix? A square matrix, this consists of same number of rows and column. This consists of same numbers of rows and what? And column. Now, if a matrix contains the same number of rows and column, it is called a square matrix. For example, if you have this 2 1 6 8, we check the first row, the second row, the first column, the second column. So this is 2 by 2. We call it a square matrix. If you have this 1 4 7 8 1 9 2 5 6, we check this very well. This is first row, second row, third row, first column, second column, third column. Then we can call this 3 by 3. So it is a square matrix. A square matrix is not end-clear. If you have, for instance, if you have something like this, 4 6 8 9 1 7 2 5 5 1 0 6 8 9 2 7. Now if you check this very well, this is the first row, second row, third row, fourth row. It's first column, second column, third column, and fourth column. So this is 4 by 4 matrix. This is square matrix. The next one, which is number what? Number 5. Number 5 talks about a diagonal matrix. What's a diagonal matrix? This is a square matrix. A diagonal matrix is a square matrix with all elements 0. With all elements 0 except the leading diagonal element. A diagonal matrix is a square matrix with all elements 0 except the leading diagonal element. Except the leading diagonal element. Now, what is example of a diagonal matrix? We have something like this. You have 4 0 0, you have 0, you have 8, you have 0 0 0, you have 6. Now we check all other elements 0 except this. Except this leading diagonal element. You can have 7 0 0 1 as well. This is others are 0 except this leading diagonal element. So we call this type of matrix diagonal matrix. So whenever all elements of a matrix is 0 except the leading diagonal matrix and diagonal elements, we call them diagonal matrix. Next one, a unit matrix. A unit matrix. Yeah. This can also be called an identity matrix. Identity matrix. So unit matrix, this is a diagonal matrix in which the leading diagonal elements are all unity. They are all unity. Example. The identity matrix is like this. You know, instead of everything, instead of these leading diagonal elements to just be anyhow number, it should be what? It should be 1 throughout. So if you, this one is 3 by 3. Don't forget, let's do 2 by 2 as well. That'll be 1 0 0 1. So this is 2 by 2. So the leading diagonal matrix like this will be what? Will be 1 for the unit matrix or for the identity matrix. Right. It is denoted by I. It is noted by I. So sometimes the examiner can ask you that what is 3i if the matrix is 2 by 2. So if the matrix is 2 by 2, what's 3i? You should know that 2 by 2 identity matrix, it will be 1 0 0 1. So it will now be 3 multiplied by 3i will now be 3 multiplied by all these one. That will be 3 times 1. That's 3 0 0 3. So this is 3i, 3 identity matrix. So this is identity matrix number 7 now. Before I proceed, don't forget that I said unit matrix is a diagonal matrix. So it's a diagonal matrix, and diagonal matrix is a square matrix. So that means both diagonal matrix and unit matrix must be square matrix. Either 2 by 2, 3 by 3, 4 by 4, 5 by 5. So that is it. It must be square matrix. But you should know the difference between the unit matrix and what? And the diagonal matrix. So now, number 7. Number 7, we have what is known as a null matrix. Null matrix. This is a matrix. This is a matrix which elements are all 0. Which elements are all 0. It can also be known as zero matrix. For example, we have 0 0 0 0 0 0. So this is zero matrix. You can also have 0 0 0 0. It is zero matrix. So if you have all elements of a matrix to be 0, it will be called zero matrix. Number 8 now. Number 8, we talk about the transpose of a matrix. Transpose of a matrix. This is the conversion of rows to column, or column to rows. This is the conversion of rows to column, or column to what? To rows. It is denoted like this. The notation is T. Now, for instance, if you are given A to be 4A C7, and you are asked to find A transpose, the transpose, you can either convert rows to column or column to rows. Now, the easiest way, let's convert rows to column. Now, this is the first row, this is the second row. So take the first row to the column, so it becomes 4A like this. Then the second row to the column, that will be C7. So this is the transpose. If you are given matrix B to be 2AB 7AC G4 1, and you are asked to find the B transpose here, the B transpose here will now becomes, now convert the first row, the second row, the third row. So let's take the first row to column. The first row here will now be 2AB. Now the second row, that will be 7AC. The third row, G4 1. So this is the transpose of a matrix. Now matrix C. Matrix C, if you have 8 minus 1, 5. You have 7 to 6. What will be the transpose of this matrix? This is row 1, this is row 2. So C transpose here will now be, so the first row to column, that will be 8 minus 1, 5. The second one will now be 7 to 6. So this is the conversion of rows to column, or conversion of column to rows. So this is all about the transpose of a matrix. Now if you want to do this on the calculator, the first one, let's say you want to do the first one here, or let's deal with the one that has the number here. Let's do this one. So if you press your mode, you go to vector, that's 8, vector A. So vector A, sorry, it's not vector, let's press it again, mode, matrix, that's number 6. Go to number 1, matrix number 6, matrix A. Now the matrix you want to insert here is how many rows, how many columns. This is, the rows here is 2 rows and 3 columns. You can see that will be 2 by 3, as I taught you under order of the matrix. 2 by 3, that's number 4. So now we're now inserting rows. The first one is 8, then press equals 2. Next one is minus 1, you press equals 2. Next one is 5, you press equals 2. Next one is 7, you press equals 2. Next one is 2, you press equals 2. Next one is 6, you press equals 2. Then press AC. We are asked to find the transpose of this. So the transpose of this, you'll be using shift of the matrix here. And transpose is number 8. Still press shift, matrix here. You know we use number what? Number 3. So transpose of matrix A, press equals 2. What do you have? You have 8, 7, minus 1, 2, then 5, 6. So this is how to do the transpose on the calculator. So now, the next aspect, number 9. Before we move to number 9, you should all know that if you ask to find transpose of a transpose, your answer is that matrix. So A transpose will be A. B transpose will be what? Will be equal to B. Now they ask you to find matrix A multiplied by matrix B or transpose. It can be equal to matrix A transpose multiplied by matrix B transpose. So you should note this. So let's go to number 9. Number 9 now. We have under the number 9, we have what you know as symmetric matrix, or symmetric matrix. A matrix is said to be symmetric. A matrix is said to be symmetric if it is equal to its transpose. If it is equal to its transpose. So therefore, if you are saying matrix A is symmetric now, matrix A can only be symmetric if it is equal to a transpose that is. So we have A equals to A transpose. For example, if you are given matrix B to be equal to 7, 6, 3, 4, 2, sorry, we have 6, 2, let's say you have 8, now you have 3, you have 8, then you have, let's say 7, or let's say 0, let's say 0. Now if you check this, let me write again. You have B to be 7, 6, 3, 6, 2, 8, 3, 8, 0. Now let us find the transpose of this. If we want to find the transpose of this, B transpose, let us convert the what? The rows to column. This is row 1, row 2, row 3. So converting this row to column, the first row bring it here, that will be 7, 6, 3. The second one, let's bring it here, that's 6, 2, 8. The third row bring it here, 3, 8, 0. Can you see that the matrix B is equal to its transpose? We look at it very well, is equal to its transpose. So if this occur, then we now see that this matrix is symmetric matrix. Number 10. Skew-symmetric matrix. Skew-symmetric matrix. A matrix is said to be skew-symmetric if it is equal to its transpose in opposite sign. If it is equal to its transpose in opposite sign. So that is what we know as skew-symmetric. If it is equal to its transpose in opposite sign. For example, if you have matrix A to be 0 minus 3, 4, you have 3, 0 minus 8, you have minus 4, 8, 0. Look at this. If you now want to find the transpose of this, the transpose will now be this is row 1, this is row 2, this is row 3. So take the first row to column. That will be 0, minus 3, 4. The next row to column, that will be 3, 0, minus 8. The last row to column, minus 4, 8, 0. Now if you observe, 3 here is minus, but here is 3. It's plus 3. 4 here is plus 4, but here is minus 4. 3 here is plus 3, but here is minus 3. 8 here is minus 8, but here is what? Is plus 8. 4 here is minus 4, but here is plus 4. 8 here is plus 8, but here is what? Minus 8. But you can observe that each of the numbers that are here are the numbers that are here as well. But the only thing that is different is what? The sign. So if a matrix can be equal like this, we'll call it skew-symmetric matrix. The next one, number 11. Number 11, we talk about equal matrix. Equal matrix. Now, two or more matrices which are of the same order. That is, what do I mean by the same order? They have the same rows, the same column. Is said to be equal if and only if their corresponding entries are equal. Take note again. Two or more matrices are said to be equal if and only if their corresponding entries are what? Are equal. If and only if their corresponding entries are equal. That's what they call what? That's what they call equal matrix. Now if you have matrix A to be 2, 6, 1, 8, 0, 7, and matrix B to be 2, 6, 1, 8, 0, 7. Can I see? So we can now say that matrix A is equal to what? Matrix B. But examiner will not set this simple question for you as if is this. No. We have to give you some questions. Now let us look at some questions under this before we proceed. If You have 4x minus 3y, 5 minus 3, 8x minus y equals to 10, 5 minus 3 minus 10. That's it. Find x and y. So find x and y. So if you want to solve this, since you find x and y, you should know that they said this is equal to this. That means this side is equal to this side. This side is equal to this side. Side is equal to this side. This side is equal to this side. So if you bring the equation, 4x minus 3y is equal to 10. Then this side should be equal to this. That means 8x minus y is equal to minus 10. According to it. Now if you now check this, we can proceed. This is equation 1. This is equation 2. Now how can we find x? And how can we find what? Y? We have different methods we can use. Let's use this method. Let's multiply equation 1 by something that can cut this. So let's multiply equation 1 by 2. So that if you multiply all equation 1 by 2, the x here we have the same coefficient. Let's do that. 2 times 4x, that's 8x. So if we multiply equation 1 by 2, we multiply this by 1. So that's all. So 2x, then 2 times minus 3y, that's minus 6y. So because 2 times this will be what? 20. Then equation 2 by 1, that will still be what? 8x minus y equals to what? Minus 10. Then let us eliminate. That is using subtraction method, elimination method. If we want to eliminate, 8x minus 8x will be 0. Minus 6y minus y, that will be minus 6y plus y. So if you remove 1y from minus 6y, that will be minus 5y. So minus 6y minus y, that will be minus 6y plus y, minus 5y. Then 20 minus 10, that will be 20 plus 10, that's 30. So from here, y is equal to 30 over minus 5. The answer is minus 6. Now if y is minus 6, what is x? We can insert x in any of this equation. Let's use equation 1. That means equation 1 is 4x minus 3y is equal to 10. So 4x minus 3 into bracket minus 6 is equal to 10. So 4x minus 3 multiplied by minus 6, that's plus 18, is equal to 10. Then you can have 4x to be equal to 10 minus 18. So 4x is minus 8. So x will be minus 8 over 4. That's minus 2. So x is minus 2. Then y is what? Y is minus 6. We can do this on the calculator. Press your mode. Then go to your equation. That's number 5. Then go to number 1. And number 1, we can see. Once you know that this, if you are given in the question, once you know that this is equal to this, then this is equal to this. Don't forget, those are the things we brought out here. This is equal to this, which is equation 1. This is equal to this is equation 2. So now insert this on the calculator. The first one, once you get to this place, the coefficient of the x here is 4. So press 4 and press equals to. Next one is minus 3. So press minus 3 and press equals to. Next one is 10 here. The equals to here is 10. So press 10 and press equals to. It shifts to the next one. The next one, the coefficient here is 8. Press 8 and press equals to. Next one, you have what? The coefficient of y here is minus 1. So press minus 1 and press equals to. Next one here is minus 10. So press minus 10 and press equals to. Then press equals to. You observe that x is minus 2 here. Then press equals to again. Y is what? Minus 6. So you have x to be minus 2 and y to be minus 6. So that is how to do this on the calculator. Let's solve another question under this aspect. If you check this question says, if you have this to be equal to this, find x and y. Can you see now? We can break out the equation. This one is equal to this. So that means y plus z is equal to this. 0 is equal to 0. 4 is equal to 4. 3 is equal to this. This is equal to this, which is 3x minus y minus z is equal to minus z is equal to minus 7. This is equation 1. This is equation 2. 2 is equal to 2 here. This one is equal to this as well. That means we have x plus y minus 3z is equal to minus 13. Equation 3. 6 is equal to 6. 5 is equal to 5. Now, If you check this very well, you can use any method to solve this question, but let's solve using AND method first before we now go into the calculator method. Now, if you see this question, in this equation, we can just say that from equation 1, I can say that y is equal to 6 minus z, because if you take z to this side, it will become what? Minus. So y is equal to 6 minus z. Take note. Now let us insert that's y in equation 2. So equation 2 becomes 3x minus y minus z is equal to minus 7. So this is 3x minus, what's your y? Your y is 6 minus z. So we have minus z here equals minus 7. Then we have 3x, open this bracket, minus times 6 will be minus 6. Minus times minus z will be plus z. Then we have minus z here equals minus 7. Then from here we can say 3x minus 6 plus z will cancel minus z. So that one is cancelled. That's, we have minus 7. So 3x will now be minus 7 plus 6. So 3x is what? Is minus 1. So x will be minus 1 over 3. Now if x is minus 1 over 3, let us insert the value of x in equation 3. So from equation 3, we have equation 3 to be x plus y minus 3z equals minus 13. Now let us see. So our x is minus 1 over 3. So plus, what's our y? We have y to be 6 minus z. So minus 3z equals minus 13. Now open this bracket. We have minus 1 over 3 plus 36, that's 6. This one will also be minus z. Minus 3z is equals to minus 13. Minus 1 over 3 plus 6. This one will be minus 4z equals minus 13. Minus 4z will be equals to minus 13. If we take minus 1 over 3 to this side, it becomes plus 1 over 3. If we take 6 to this side, it becomes what? Minus 6. So minus 4z is equals to, let us press on the calculator, minus 13 plus 1 over 3 minus 6. So the answer is minus 56 over 3. So this is minus 56 over 3. So z will now be minus 56 over 3 divided by minus 4. So z will now be, let's calculate, as minus 56 over 3 divided by minus 4. So the answer is 14 over 3. So we have this to be 14 over 3. So x is minus 1 over 3, z is 14 over 3. Then we've gotten x, we've gotten z, we need y. So don't forget, y is equals to 6 minus z. So y will now be 6 minus, what's our z? 14 over 3. So y will now becomes, that's 14 over 3, sorry, that should be 6 minus 14 over 3. And the answer is 4 over 3. So x is minus 1 over 3, y is 4 over 3, then z is 14 over 3. Now let's use the calculator method to solve this. If you want to solve this using calculator method, you press your mode, you go to equation, that's number 5. Then use number 2. Number 2 is x, y, z. Now if you check, for this first equation, we are not given x. So since we are not given x, you press 0 for the first one. Next one is the coefficient for y. The coefficient for y here is what? 1. So 1 equals to, then z is also what? 1 equals to. This is what I'm trying to say. Now if you have, now see this equation, this equation, this is what we want to press. You know, let me redo the calculator method again, so that assuming you want to use the calculator method straight up, you don't want to use the normal and method. Now see this. In the equation we are given, this is the question given to us. Now this question given to us, we have y plus z is equals to this side, which is 6. Then this one as well, which is 3x minus y minus z is equals to minus 7. You check it very well. And this side is equals to this side as well, which is x plus y minus 3z is equals to minus 13. Now, if you check this equation very well, the one we wrote as well, you observe that this equation is x, y, z. This one is also x, y, z. But in this first equation, there is no x there, so we use it to be 0. So it will be 0 plus y plus z is equals to 6. So that's it. So this one will be 3x minus y minus z is equals to minus 7. And the third one is x plus y minus 3z is equals to minus 13. So let us now press on the calculator. Let's press again. Press your mode. Go to equation, that's number 5. We use number 2. Now for the first one, the value of x is 0. So we don't have x there. So that's 0. Press equals to y. The coefficient of y here is 1. So press 1 and press equals to. The coefficient of z here is also 1. Press equals to. What is equals to here? 6. Next one here, coefficient here is 3. Next one is minus 1. Next one is also minus 1. The equals to here is minus 7. Next one here is 1. Next one here is also 1. Next one here is minus 3. And the equals to here is minus 13. We have to repress again, please. It's because of the calculator. But it's because you have number 2. So you know 0 equals to 1 equals to 1 equals to equals to 6. So one is 3. You have minus 1. You have minus 1. You have the equals to here to be minus 7. We have here to be 1. You have here to be 1. The coefficient of here is minus 3. And the last one here is minus 13. Then press equals to. What's x? X is minus 1 over 3. Press equals to again. Y is equals to 4 over 3. Press equals to again. Then z is what? Is 14 over 3. And that is what we got from the what? From the AND method as well. So that's it. The next aspect. Now see this question. It says this minus this is equals to this. So all we just do is that you have the equation x here minus the side of the x, which is 2 plus 2x, is equals to the side of the x. We are picking the same side, that's 4. And the other one here, that's y over 3 minus, what's the side of this y over 3? That's 5. Is equals to the side, that's minus 3. Come to this, we have 2u minus the side of 2u is 3. Then is equals to what? 2. And the other one, you have 6 minus v is equals to what? 3. Now, this is equation 1, equation 2, equation 3, equation 4. We have to find x, y, u, and what? And v. Now, since we are asked to find this, I can solve this from any equation. From equation 1, I have x minus 2 plus 2x is equals to 4. Let's open this bracket. Minus this will be minus 2. This will also be what? Minus 2x is equals to 4. Minus the effect. So we have x minus 2x minus 2 equals 4. So x minus 2x will be minus x. So minus 2 equals to 4. So minus x is equals to 4 plus 2. So minus x is equals to 6. So x will now be what? Minus 6. So since x is minus 6 from equation 1, then let's go from equation 2. Equation 2 says y over 3 minus 5 is equals to minus 3. So y over 3 will be equals to minus 3. If you take minus 5 to this side, it becomes plus 5. So y over 3 is equals to what? Is equals to minus 3 plus 5, it will be 2. If you cross multiply, y is equals to 6. So y is equals to 6. So let's go from equation 3. We have 2u minus 3 to be equals to 2. So 2u will be equals to 2. If you take minus 3 to this side, it becomes plus 3. So 2u will now be 5. U will be 5 over 2. That's from equation 3. Now lastly, from equation 4, we have 6 minus v to be 3. Then 6. If you take 3 to this side, it becomes minus 3. Then take minus v to this side, it becomes v. Again, we have 6 minus v to be equals to 3. Take this 3. You know it's positive before. If you take it inside, it becomes minus 3. This minus v, if you take it outside, it becomes plus v. So 6 minus 3 is 3. So it's equals to v. So that shows v is equals to 3. So you can see x is minus 6. Y is 6. U is 5 over 2. The v is what? Is 3. Now see this question. The question says, if this side is equal to this side, so that means we have two equations that we can use. X squared minus x plus 1 is equal to 7. From this 1 to be equal to this. Then 7 is equal to 7. Then 0 is equal to this. We have 0 to be equal to x squared minus 7x plus 12. This one is equation 1. This one is equation 2. Don't forget x is equal to x here. So we are asked to find x. We have to find x. Now check the value. In this equation, I can say the equation 1 is x squared minus x plus 1 is equal to 7. So x squared minus x plus 1. If you take plus 7 to this side, it becomes minus 7. Everything equals 0. So x squared minus x minus 6 equals 0. So this is the quadratic equation for the first equation. Now the second equation is x squared minus 7x plus 12 equals 0. If you change it like this. So this is the quadratic equation from the second equation. So can you see now? Now I can solve this using the calculator method. If you are using AND method, you know how to solve quadratic equation. So just solve the quadratic equation of this and the quadratic equation of this. But don't forget, we are still going to end up at the same answer. Solving the quadratic equation of this one first. For this first equation, we have the first mode, first equation, number 3. Press the coefficient. The coefficient of x squared is 1. So we press 1 equals 2. Next one is minus 1. Then the third value here is what? Is minus 6. Then press equals 2. You can see that x here, x1 is 3. x1 is 3. Then when you press equals 2 again, you see that x2 is what? Is minus 2. So our x2 is minus 2. But for this one, let's press this value. You go to equation number 3. Let's press the coefficient. Coefficient of x squared here is 1. Next one here is minus 7. Next one is 12. Then press equals 2. You can see that x1 is what? Is 4. Then press equals 2 again. Then x2 is what? Is 3. Now these are the values. Now these are the possible values of what? Of x. But we can see that 3 is common between what? Between the two equations. So if you want to pick the right answer here in the option, then the answer will be what? Will be 3. Yes, because 3 goes in what? In the two equations. And we are talking about the equation that we are going to insert that will make this to be equal to what? To this. So the best answer here is that our x is equal to what? Is equal to 3. So now, because 3 is common between the two equations, this and what? And this. Now, let us see the next question. Now, we have to end this section here. So please and please, at the comment section, let me have the answer to this question. This question says, if this is equal to this, now what is the possible value of x and y? Now let me have the answer at the comment section. You have to be very, very patient because this matrix, we still have a lot to do under it. We still have an aspect of singular matrix, non-singular matrix, Hermitian matrix, we have the conjugate matrix, we have determinant of the matrix, we have conformable matrices, we have additional and subtraction of matrices, we have multiplication of matrix, we have inverse of matrix. That is, under the inverse we'll be dealing with the adjoint, conjugate, cofactor rather. Now under this aspect, I'll be giving you the calculator method so that it will help you to solve the question in short period of time. But because of the time, let us short this one here. Let me have the answer to this aspect at the comment section. What is the value of x and y? I remain Ishola David, blessing by name, popularly known as General David. God bless you. Like, comment, and subscribe for more videos. Thank you very much. God bless you.